Today on Between the Lines, the search for extraterrestrial life and its implications for our future with astronomer Jeffrey Bennett. I'm Barry Kibrick. Dr. Bennett is an astrophysicist who believes that the search for life on other planets can help bridge the divide that exists between us on this planet. With his book, Beyond UFOs, he shows us why the very quest to find alien life can help us to grow up as a species and chart a course for the stars.
I'm a writer today because I was a reader when I was 11 years old, and it was...
You do not need to prove your state of happiness to anybody.
Most of these speeches were as much as a month in preparation.
Characters, the heroes in this book, are seekers of truth in a story that involves a lot of corruption.
You don't get a chance to really talk about what's real, and it's the purpose to me.
Jeffrey, it's been a very long time. Welcome back to the show. Nice having you here again.
Thank you so much for having me again, Barry. I really appreciate it.
It's my pleasure. I'm going to begin with what I'm certain of is your thesis for this book, and it's this. This book will take you on a short journey through the world of science and what it has to say about the possibility of life beyond Earth. This is a book about possibilities. By the way, is not physics in our modern time all about possibilities?
Well, it's very much about possibilities, and I like to talk about science as a way of distinguishing possibilities from realities. Well, we start out with lots of possibilities, and then we try, as we learn over time, to figure out which of those possibilities might actually be reality, which ones are not reality. You can go back to the time when the idea of Earth being the center of the universe was a possibility, but we now know that that's not the reality. So we're always looking to try to separate the possibilities from the realities.
Within your own life, that happens. You recall as a young boy what you believe is an experience of a visitation from aliens, but as you grow up, and I think this is important, because I think it also gets to the heart and soul of your message. My imagination was far too limited, you write. The real world holds wonders far more mystifying and incredible than anything my young mind could have had conjured up. And that's also what this is a book. It allows us to see the awe in reality, in life, in science, in the universe.
That's right, and I think that sometimes science gets caricatured because sometimes it will tell us this is not possible, that people say, oh, it's limiting to us, but it's not. Once you realize what things are possible and what things aren't, it always opens up even more questions and even more possibilities that you hadn't thought of before. So the process of science is always one of learning more and more and more and having greater and greater awe about the universe and what our place within it might be.
Well, your, in fact, entire study, you say the origin of life could be figured out by this, the origin of our intelligence, the nature of the human mind, and the survivability of our civilization could actually be hinged on us continuing to look beyond the UFOs.
That's right. If we don't understand who we are, what we are, and how it's possible for us to be here, then it's going to be very difficult for us to make intelligent choices about our future. But when it comes to this idea of could there be aliens out there, could there be other life in the universe, other intelligences in the universe, we can actually go out and study like that. For example, I like to say that even aliens need a place to call home. That means the first step in looking for alien life is to figure out whether there's places where they could have grown up, where they could live, worlds, planets, and in particular whether there might be Earth-like planets if we're going to look for intelligent life. And over the last few years, we've begun to discover that there are planets around other stars. We have a mission just launched in March called Kepler that should, I believe, in the next 3 or 4 years, show us for sure that other Earth-like planets really do exist. And once you establish that, then you can look at the number of Earth-like planets out there, and based on some very reasonable guesses, you come out with enormous numbers of possibilities.
But I want to talk about something that you mentioned before. You just said Kepler, and that name stuck in, and I just was looking through my notes and I found out why. You really have this passion for Kepler, and I thought it was interesting. You say Copernicus is a revolutionary. Tycho Brahe was the one that collected the data. Galileo and Newton did the work. But for the money, it's Kepler, you say. to whom we must owe the birth of modern civilization. And this reasoning is so important because he did something that no one else had ever been willing to do. He trusted the data more than he trusted his own deeply held beliefs. That's probably the classic break in modern science.
Yes, Kepler had this very deeply held belief that heaven had to work in perfect circles, as Plato had said a couple thousand years earlier. And he could not make the data fit that. And he came so close, within 8 minutes of arc, which is, less than the width of your little finger held out at arm's length. He came that close to being able to make the data fit perfect circles. But that tiny little error, he could have said, if he wanted to stick with his beliefs, he could have just said, the data are wrong. But he didn't. He said, I believe the data, and therefore my deeply held belief must be wrong. And so he tried something new, and he actually came up with ellipses as being the correct shapes of planetary orbits. And that willingness to say that what we observe in the universe is more important than whatever preconceptions we might have about it is what distinguishes science from other forms of thought. In science, we let reality steer us as we look for truths in the universe.
It's really a heroic break when you think about it, because, and I was questioning even that, because there's almost something that I want to resist, even in that thought. Why data over beliefs? Beliefs could be deeper than data at certain times, but on a philosophical level, not necessarily on what is really going on.
The beliefs can be very deep, and one of the interesting things, I talk a lot about the science and religion issues, in very few cases do they actually overlap. But when you have an overlap, you have to make a decision. And actually, if you look at it, despite what you might hear about the contentious things in society today, throughout history, religion has always adapted to the data and to the realities. Sometimes it took some time, like with the story of Galileo and the Catholic Church, but it has adapted. And I think the reason it's so important is because those deeply held beliefs are what we live by. And if we have deeply held beliefs that are based in something that's not true, then we're not living in a true way. We're living in a false way. And if you go back in time to when people thought the Earth was the center of the universe, that inspires a certain type of thinking about yourself and your place in the universe that's very different once you realize we're just on one planet around one star among a vast number of stars and galaxies.
But at the same time, you're a little tricky, Jeff, because you do also, you leave us with a sense of our specialness as well. I'll give you an example. You brought out a fellow, Freeman Dyson. I wasn't familiar with the name before, as much as I should have been. But I remember hearing it, and I thought, oh, wait a minute, now I'm putting it together. But your words that, or I should say his words that you bring out, the more I examine the universe and study the details of its architecture, the more evidence I find that the universe, in some sense, must have known we are coming. So there does seem to be a strong implication with that thought of consciousness. I don't know exactly what it is, where you're going with it, but you brought that in there, and yet you were careful to say we're not the center of the universe, yet we seem to play a very unique role to at least our understanding.
Well, I talk later about one of the possibilities. What if we are alone in the universe? It seems to me almost impossible to imagine that could be the case. But what if we are? Since we don't have proof yet that we're not, it's still a possibility that we're alone in the universe. And what would that mean? Well, what that would mean is that over the last 14 billion years since the Big Bang, and out of all these stars that, as I talk about number, there's as many stars in the observable universe as there are grains of sand on all the beaches of Earth put together. Out of all of that, right here in our heads is the only place that the universe knows it exists. We are the self-awareness of the universe. Now, I actually think there's probably a lot of other self-awareness points in the universe, other life forms out there that have realized this too. But if there's not, then it's only here. And even if there is, it does not diminish our accomplishment any more than the fact that there's 6 billion people on Earth makes any one of us any less important than the others.
Well, you know, I always used to tell guests, I said, you know, if there's a guy in a chair up there with a beard determining this, Or if we all just oozed out of the primordial soup, isn't it still awesome? And that's the sense I get from you as well. If we're the only people or the only intelligent life, that's awesome. And if there's tons of us floating around this universe, that's awesome. No matter how you look at it, there is an awe and something that, as you underlie here, we've got to respect and be grateful for.
That's right. And I think we have to really appreciate what we are capable of. And the fact that we can understand these things, the fact that we've learned these things about the universe, that we can study the universe, is incredible. And we need to give ourselves credit for it, for being able to do that. The fact that we're small physically in the universe doesn't mean that we're unimportant. It means we should recognize that it's rather silly to go fighting about little tiny pieces of land or fighting about whose religion is better than the other person's religion. But it doesn't mean we're not important.
Let's talk about what else is important. 3 properties of life. Life creates order out of chaos. Life makes copies of itself, but not quite perfectly. And life evolves through time. Those 3 properties, and then you give us the sense that there's an element or two, a liquid medium somehow needs to be there, and carbon. Carbon I've now been reading about. The more I understand carbon, the more special things seem, because carbon seems to be this offshoot element somehow that does an amazing thing that the rest of the universe, it's hard for us to find it happening anywhere else.
Yes, well, carbon is special on the periodic table of elements because it's in the column where you're able to bond to 4 other atoms simultaneously. So it's not the only element with that property. Silicon is the most famous other element that has the same property. But carbon seems to be the one that it has a few other advantages over silicon. And also, I think we look at Earth and we find that Earth actually contains more silicon in its crust than carbon. Yet we have carbon-based life. And to me, that tells us that carbon was a better choice for life. Otherwise, silicon would have done it. Now, there are science fiction writers who like to debate that, and science fiction writers who've imagined silicon-based life and other elements that might be able to do that as well. And there are possibilities, but I suspect that carbon wins out because wherever you find the others, you're going to find carbon. And our example of Earth suggests maybe carbon's going to get there first.
With that in mind, let's go back to the 3 properties. Life evolves through time. You mentioned how Darwinism is the most misunderstood. It literally, it's the one that, it's the monkey wrench still in, oh, that's fine, I didn't even mean that as a pun, but it is the monkey wrench thrown in our religious science debate, and it really doesn't need to be.
It doesn't need to be, and it's a misunderstanding, and actually I think it's a misunderstanding on both sides oftentimes. But you know, when you ask the general public which do they believe, and they're just as likely to say they believe creationism as Darwinism, I don't find that too surprising given the way we've taught evolution, which is very poor. And if you haven't actually learned what the evidence behind it is, then why should you accept it? That would be accepting it on faith, and we don't want people to have to do that. But when you look at the evidence that underlies the theory of evolution, it's very, very compelling, which is why it's pretty much universally accepted among scientists. And when you talk about that with people who may be coming from a religious point of view where they didn't think that was what they were going to believe, once they look at the evidence, they can say, you know, wow, that's something I hadn't considered. Maybe I can reconcile that with my religious beliefs rather than having them be in conflict.
Well, you do it for us even. In the book, let me see if I get this right. All known life on Earth, and again, through Darwin and evolution, evolves from a common ancestor. But it never says what made or why did that common ancestor even exist. So religion can always still play within the folds of evolution.
That's right. We don't know what starts it off, what it does. So there shouldn't be any inherent conflict. And for most religious folks, there's not. The Catholic Church certainly has no problem with the theory of evolution, for example. It's a relatively small group of people, and I think that for the most part, it's due to misunderstanding, and sometimes it's due to scientists who do the opposite thing of not understanding where the religious people are coming from.
Well, let's go back to the science for a second. We're talking about life and science together here. So 3 hallmarks of science, you say, and one of them is the one I want to ask you about. 1, seeks explanations for observed phenomena that rely on natural causes. Another that must make testable predictions about natural phenomena. But this one here, progress that explains the observations as simply as possible. And most of us never think of science as simple as possible. It seems like in our educational system, it's supposed to be the most confusing thing. The truth is, though, explain the depth, because I found that to be so deep, of being as simple as possible as a major hallmark of what science is.
That's right. One of my favorite stories, you may be familiar with this one, is Richard Feynman when he was getting his Nobel Prize.
I had his wife on my show with all of his letters, by the way, and
that must be
it was
incredible.
just fantastic. He was something, but please share that story.
Yeah, so I think it was the Queen there said, "Oh, Mr. Feynman, you must be so incredibly intelligent to study something so complex as physics like this." And he said, on the contrary, physics is very simple. There's simple rules and simple ideas, and you just work them out. Economics, politics, social sciences, that's the difficult thing. Physics is simple and easy once you put some time into it and study it. And that's what physics has always done and science has always done, is it shows us the underlying simplicity of the universe.
You know, this is between the lines, and you have a thing you do on scale. And the reason why I brought up the name of the show is because it's what's between all the scale models that is so amazing. But give us just some example of the scale of this universe, because when you use that thing about the sun being a grapefruit, I'll have you do it. It's beautiful. And I think when we realize that in the weirdest thing, almost all existence is nothingness. But go ahead.
Yeah, it's quite amazing. It's one of my favorite things to work on and talk about. So I like to use a 1 to 10 billion scale, and we've built a couple
Say
of...
that a little clearer.
1 to 10 billion. So everything is shrunk down 10 billion times. And by the way, these scale models, we have one at Boulder, was the first one that I did at the University of Colorado Boulder, and we have one on the National Mall in Washington, D.C. outside the Air and Space Museum. And just recently they opened in Kansas City and Houston, and we're working on putting them in a number of other places. But on that scale, the sun ends up about this big, like a big grapefruit. Earth on that scale, remarkably enough, is about the size of the ballpoint in a pen. And it's 15 meters, 16 and a half yards away from that sun. So you get that sense of what that little tiny ballpoint going around that grapefruit once a year. That's the orbit of Earth around the sun. The moon is only that far away from Earth. Earth, moon on that scale. The farthest human beings have ever gone. To get to Pluto, where the New Horizons mission is on its way to now, you've got to go about 1/3 of a mile. To get to the next star,
This is the one that gets me. To get to the next star.
it's the distance across the United States. So you look right away, and I talk about this with the aliens. If aliens are visiting us, they're coming from across the United States when this is the farthest distance human beings have ever traveled, Earth to the moon. To scale. And that's just to the nearest star. To go beyond that, now you've got to go back to what I mentioned earlier, the as many stars as grains of sand on all the beaches on Earth put together. And on average, every pair of them separated, like a grapefruit here and a grapefruit across the United States. It's just stunning.
But the vastness of it, it's where the possibility comes in again. If you're just playing poker even, you'd have to say, the odds are, that's what you do here, the odds are that somehow or another, this conglomeration, if there is a trillion stars, and by the way, we were at first just talking about our galaxy. When you're talking about the nearest star, you're talking about in our galaxy.
Right.
The nearest galaxy to our galaxy, I don't even know what in scale that is, but it's probably more than the distance between the United States.
Oh, you can't even, once you get beyond the first few stars, you can't even fit it on the Earth anymore at this scale. You have to jump your scales. But yes, let's just take our galaxy, for example, 100 billion stars. I like to talk about counting them. It would take you, if you counted 1, 2, 3, it would take you 100 billion seconds to count them at 1 per second, which is more than 3,000 years. Just to count them in just our galaxy. If you take some lottery numbers, what if only 1 in a million of them gets a civilization at some time? You still end up with 100,000 civilizations in our galaxy alone. So yes, the numbers do make it seem like we should be in a universe full of life. Or as Carl Sagan said, otherwise it's a great waste of space, right?
It's a great waste of space. What's not a great waste of space is your website. You mind if I give it out? Because I know this type of conversation is going to spark a lot of viewers to want to check out more. And it's a real easy one to give out. It's your name, www.jeffreybennett.com. And you'll respond to viewers and things like that as well?
I try to do my best to respond. I also have an email that they can sign up for that I send out updates and so on.
You know, I told everybody too, we're discussing this book, but can I hold up a book? I'm going to hold up a book, folks, for everybody. Max Goes to the Moon. This is part of a children's series. Max goes to Jupiter. Max goes all over the
Moon, Mars, and Jupiter.
Moon, Mars, and Jupiter. So if you want to give kids a chance to start grappling with this, that's a great way to do it, because it's fun stuff to talk about. For kids, it's hard to really, this is a little complicated for most kids. Probably some kids can get it pretty well, but for most young kids, it would be. But Max series goes and helps kids, guide them to what I like best, feeling the awe of what's going on.
That's right. I'm trying to get kids to be inspired, to dream, and to want to do great things for themselves and the world.
We can feel comfortable in saying that there is life on other planets only because the fact that life on this planet does not really resemble us. This is what I loved about this concept. When you look at life on this planet, I guess it's 99.9% of all life is not like us. It's microbes. It's things that if you didn't put them under a microscope, you wouldn't know exist. And many of them exist in what we would think is uninhabitable spaces, deep volcanic wells of smoke and steam and all sorts of gunk like that. Am I correct?
That's right. That's right. It's been one of the great discoveries in biology of the last 40, 50 years. You know, we used to think when I was being taught in elementary school, there was the plant kingdom and the animal kingdom. That was like what there was for life. And now we realize that those are just two very small branches of a much greater diversity of types of living organisms, but nearly all of them are microscopic. And they do live in environments that for us, we would find lethal, but for them, they're quite comfortable.
Then there is that big leap between that life and even plant life. You even suggest that once we get to plant and animal life, coming to our life seems almost like it could have happened evolutionarily in rather quick time. But there seems to be this tremendous gap of time that happens between that microbial life and what we would consider the life we're looking for. We're not really, I mean, we'd be happy to find even microbial life, I'm guessing, anywhere, but we're really looking for the kind of life, you know, that would seem like us.
We want to be able to talk to them.
Yeah.
Yes. That's right. I think one of the difficulties of this subject of life in the universe is that so far we have statistics of one. We have only one planet, our own, on which to study and try to make inferences, and statistics of one are, of course, notoriously unreliable. But you can still say a few things. For example, life got started on Earth, apparently, quite shortly after it was possible for life to exist here.
Well, by the way, I have to tell you, that to me was one of the most amazing things. I thought that would have been the big evolutionary leap. It almost, in space-time, was instantly, or within a few 100 million years or whatever.
Within that, which could mean much more instantly than that. It just means that's an upper limit. It might have been days, who knows. But yes, it happened quite quickly, so that sort of suggests maybe that step is fairly easy. But then you go 4 billion years from the first origin of life, the simplest life on Earth, until you get complex animals and us. So that suggests that that step is much more difficult.
Well, one of the things that will get us there, though, and as an educator and author, is how we begin to think, and you use these words. Quantitative reasoning is more important than the equation-solving skills taught in traditional mathematics, and I would go further and say in most of the subjects we study. How do we make that transition?
Well, I think a lot of it has to do with how we educate our children, what we do, and what we've lacked a lot in our education system is this underlying critical thinking and reasoning. It's the same thing where we've taught them in science facts instead of the evidence and the concepts, and that's why people graduate from high school and don't understand the theory of evolution, because we have not taught them what's going on behind the scenes. And in math, we've spent a lot of time teaching them the mechanical skills, which are important, but they're not the big picture of it. The big picture is how does it allow you to think about what these numbers that we encounter in our lives mean.
You know, we haven't even probed the deep alien questions yet, but we are out of time. And time is of the utmost importance when it comes to physics. So best I can do is just end with these words. One way or the other, we will eventually find out whether other civilizations are common. It may take decades or even centuries, but unless we stop searching, we will find an answer. And I want to thank you, Jeff, for helping us along that journey.
Thank you very much, Barry.
It's my pleasure, and I want to thank you for joining us. Now, before Jeffrey leaves, I'd like to leave you with these few more words from Beyond UFOs. It's not so much what the answer to the question turns out to be that is important, but the mere fact that it must have an answer one way or other. The deeper we look into the issues that underlie the questions, the more profound its implications become. I'm Barry Kibrick. It is not so much the answers, but when you do dig deep and look between it all, the more profound it really does become. Thank you, Jeff, for the exploration.
Thank you very much.
My pleasure.
If you'd like a tape of our show or would like to become a member of our book club and receive our weekly email show updates, just write us at barrykibrick@aol.com.